All right, so if we're looking at Unit 2's review, there's only 5 questions on this one. Question one's pretty lengthy, but it's pretty accessible. So the first part is talking about, it has two different Lewis dot structures, one for fulmuric acid, or fulminic acid, excuse me, and ask you which one is the better representation. And so what you need to do with this one is figure out the formal charge. So on this one, the formal charge for carbon is 0, and the formal charge for oxygen is -1. On this one, the formal charge would be -1 for carbon and 0 for oxygen. So the question is, which one is more or a better representation? The correct one is the one on the left. It's because oxygen is a -1 and it's more electronegative than carbon, so thus it should have a negative formal charge. And remember, to calculate formal charge, you take the valence electrons, the free valence electrons, and subtract out the bonded valence electrons. Then the second part is calculating delta H, and it uses a table. You'll see that. And you just basically remember the delta H is the sum of all the bonds broken, subtracting away the summation of all the bonds formed. And that gives you a kilojoules. Then the next part of it talks about delta S, which is entropy, randomness. And it says that the student claims that delta S for the reaction is close to 0. And it is accurate because the change from fulminic acid to isocyanatic acid is just a rearrangement of the atoms with no change in the molecules, so the entropy would basically be 0. There is very little change. The next question talks about fulminic acid or isocyanic acid. Which one will be at a higher concentration at equilibrium? So you have to basically calculate delta G. Well, you don't really have to calculate it, you just have to understand delta G. Remember, delta G is equal to delta H minus temperature times the delta S. So when you do that, delta G is roughly equal to delta H, because delta S is 0. And so delta G is approximately -246 kilojoules per mole, which favors the forward reaction. And since delta G is negative, K is greater than 1, which means that a higher concentration of the product will be, there will be a higher concentration of the product at equilibrium. Then on part E, it talks about, you have a graph giving you time and concentrations, and then it has a linear plot. And the student proposes the rate law is, and gives the rate law. And it says, explain how the data supports the student's proposed rate law. Well, the decomposition reaction has a constant half-life. It halves every 10 hours. And because of that, it is a first-order reaction. And since it is a first-order reaction, you can answer part 2. You can calculate or determine the value of K. So K is equal to the natural log of 2 over the half rate or half-life. So 0.693 divided by half-life, and so that is 10 hours. So you end up with 0.069 per hour. So that would be your rate constant. And then part F, let me flip it. You repeat the experiment. It basically asks you, the student learns the decomposition was run at a solution of pH of 13. Describe an experiment where what you would change and what data you would gather. So you repeat the experiment at different pH values, above and below pH, and then record the concentration versus time to see if K changes. Okay. Question 2. talks about molecular formulas of diatomic bromine, chlorine, fluorine, and iodine, the halogens. I'd ask you which one has the longest bond length, and that would be iodide. And then it basically has you go through some half reactions and calculate the balance equation, and you calculate the value of E for the reaction. That's right there. The E of the reduced species minus E of the oxidized species. And then part C is the boiling point of bromide is 332 Kelvin, whereas the boiling point of bromium chloride is 278. Why? And it's because bromide only has LDFs, but bromium chloride has LDF and dipoles. But because of the greater because bromide can be polarized more, its IMFs are stronger and it equals a higher boiling point. Then it asks you about a 0.1 molar sample or 0.1 mole sample of bromide chloride is placed in a rigid container. So basically you have to use PVNRT. Then it asks you with the pressure or write the expression for the equilibrium constant. You can write it as this or as this. And then you have part F asks you to determine the value of it. So you have your decomposed, which it was, you have 42% of the original, 0.42 times this value gives you 0.518 atmospheres. And you find out how much bromine chloride you have left. 1.22 minus that value gives you 0.71. And then using this or this, you notice that PBR, or excuse me, the pressure of bromium chloride, you're looking at 2 times X because they're basically the same. And so you rearrange the formula and you find out that the atmospheric pressure of bromide is 0.26 and of chloride is 0.26. You substitute back in the values and you get your KEQ is 0.13. And then it asks you to, I'm sorry, I don't know why this is not working. Okay. To calculate the bond energy, and you just follow along. You just have to rearrange and remember that delta H is the sum of bonds broken minus the sum of bonds formed. Rearrange it and you can actually figure it out. And then number 3, this one was basically you had to draw molecular structure for ethine, which is this right here. And that one's a good one to remember because on number 5 it's asked again. And ethine has the shortest carbon-to-carbon bond because there's triple bonds between the carbons. And then you can figure out the shape of each of the each of the carbons based upon using the steric number. Remember, lone pairs plus bonding regions. So if you're looking at the X carbon, it would have 0 lone pairs on it. It has 3 bonding regions, so its number is 3, and that means it's trigonal planar. And over here, tetrahedral for the other carbon because it has 0 lone pairs and 4 bonding regions, so 4. So that makes it tetrahedral. Energy required to boil ethanol. The big thing is this. All the bonds that are described are intramolecular forces, and vaporization overcomes intermolecular forces, not intra. Which of the compounds is nonpolar? Either ethane or ethyne, because they are very symmetrical and thus nonpolar. Here's an example of ethyne. And then ethanol is able to form strong hydrogen bonds with water, but ethanol does not have this capability. The forming of hydrogen bonds increases the interaction between the ethanol molecules and the water molecules, increasing the solubility. That was for part F. Then question 4 is about the sea of electrons. And remember, what makes metals malleable and ductile is that those bonds can be broken and reformed quite easily, so they're equally shared and they form non-directional bonds is the most appropriate answer here. And then number 5, asking you about the hybridization of the carbon atoms in a molecule of ethine. Going back up to here, remember steric number is how you can determine this, hybridization or shape. So you're looking at the carbon, it's got 0 lone pairs and it's got 2 bonding regions, one right there, one right there. So its steric number is 2, which makes it sp. If it had 3, it'd be sp2, 4 be sp3, and so on. Okay? So hopefully those answers your questions, and I'll talk to you later. Bye.